ओके, तो पॉलीमर्स का रिवीजन करते हैं। पॉलीमर्स के रिवीजन में ज़्यादा कुछ नहीं है, मतलब पॉलीमर्स में जो थ्योरी है शुरू में तो स्टार्टिंग में थोड़ी सी थ्योरी है, वो आप खुद पढ़ लो और खुद पढ़ कर समझ आ जाएगी। और थोड़े से पॉलीमर्स हैं जिनके बारे में मैं डिस्कस कर सकता हूँ। जल्दी जल्दी से मैं रिवीजन कर दूँगा इसका, तो आपको ज़्यादा भी करने की ज़रूरत नहीं पड़ेगी, पूरे लेक्चर्स देखने की ज़रूरत नहीं पड़ेगी। आप वीडियो को पॉज करके कॉपी भी कर सकते हैं। जो यहाँ पे पॉलीमर्स होते हैं, दो टाइप जो पॉलीथीन होती है, दो टाइप की पॉलीथीन होती है। फर्स्ट पॉलीमर आई एम डिस्कसिंग इज पॉलीथीन और पॉलीइथीन यू कैन आल्सो कॉल इट। Ethene is a monomer unit for polythene, or ethylene. The monomer unit can also be called as ethylene, and when n units of this monomer unit combine, this gives result to the polythene. This is polythene. We have two types of polythene, that is low density polythene and high density polythene. So this is ethylene. When n monomer units of ethylene combine, it gives result to the low density polythene. This is low density polythene. Actually this is polythene and this is also polythene. There is no change in formula. There is no difference in formula. Where there is difference is the mode of preparation. The monomer unit for polythene, either low density polythene or high density polythene, is ethene or ethylene. But in low density polythene, we made it at 1000 to 2000 atmosphere. We maintain the pressure at 1000 to 2000 atmosphere, and 350 to 560 Kelvin. This reaction is taken at 350 to 570 kelvins, and in the presence of O2 or peroxide catalyst. When we combine the various monomer units and monomer units at the pressure of 1000 to 2000 atmosphere, at the temperature of 350 to 570 kelvins, and in the presence of O2, oxygen or peroxide catalyst, then what we get is low density polythene. Low density polythene can be made by the free radical mechanism. This is a branch chain polymer, and molecular weight for the low density polythene is 2000 AMU units, or you can say units. Melting point for the low density polythene is 384 Kelvin. Density of the low density polythene is 0.92 ppm per centimeter cube. Now high density polythene. High density polythene has monomer unit ethene or ethylene same, and the molecular formula for the high density polythene is same, but the mode of preparation is different. Let me show you. This is ethene, this is ethylene, but this reaction is carried over 60 to 70 degrees Celsius only, and the pressure is maintained at 6 to 7 atmosphere. And this reaction is carried out in the presence of CH3, CH2, all thrice Al plus TiCl4. Okay, remember this. And this is the coordination polymerization. This reaction is carried out by the coordination method of coordination polymerization, where the low density polythene is carried out by the mechanism of free radical mechanism. Melting point for the low density polythene, high density polythene is 403 Kelvin. The other point for low density polythene is 384 Kelvin. Density of high density polythene is 0.97 gram per centimeter cube. And this, you can see that there is no much difference in densities of the low density and high density polythene, but comparatively there is a difference, so we classify them into low density polythene and high density polythene. Mechanism of preparation for the low density polythene. This is the ethene. When this reacts with O2 or H2O2 peroxide molecule, what is peroxide? Peroxide, where there is single bond between the two oxygen atoms, then we call the compound as peroxide. In the presence of this, peroxide is usually used to make free radicals. When they combine with O2 or S2O2, ethylene combined with free radical is formed. This electron comes to this and this electron comes to this. CS2, CS2, free radicals are formed. Now we saw that there were n number of ethylene molecules. This is another ethylene molecule. There were n so many, so this was another one, and these free radicals combined with these molecules. So CS2 and this made another free radical. This CS2 combined with this, and this electron came there, and this electron came there, and this is formed. Then this combined with another CS2 molecule, and various combination take place, and free radical mechanism. By free radical mechanism, a long chain is formed, and after much time this stops and polymer is formed. And low density polyethylene has low moderate tensile strength. Tensile strength is moderate, transparent, poor conductor of electricity, chemically inert. Chemically inert means it doesn't react with anything. It doesn't react with anything. That is not the thing that it will not react with anything, but it doesn't react with various molecules. So what is the example? Carry bag and bottles, and used for insulation because it's a poor conductor. It's used for insulation. Insulators, as an insulators, it can be used. Because of poor conduction, it can be used as an insulator, and which we can say as it can be used for insulation. High density polyethylene has high tensile strength. Translucent partially can be it can partial can be seen through this. Examples are pipes, bottles, and buckets. Okay, thank you. Another polymer here we have is Teflon or polytetrafluoroethylene. So monomer unit for the Teflon or polytetrafluoroethylene is NCF2 double bond CF2. Since there is double bond, this is the example of addition polymerization. And here also peroxide is used. This is peroxide. Peroxide is used as catalyst, or NH4 whole 2s H2O8, which is also known as ammonium persulfate. Ammonium persulfate. NH4 whole 2s H2O8 can also be known as ammonium persulfate. When n monomer units of CF2 double bond CF2 combine, what is it is tetrafluoroethylene. Tetrafluoroethylene. It is tetrafluoroethylene. Tetrafluoroethylene. This compound is tetrafluoroethylene. When many monomer units of tetrafluoroethylene combine in the presence of peroxide H2O2 or ammonium persulfate, or in the presence of ammonium persulfate at high pressure, then it gives result as Teflon. And it is highly inert, काफ़ी ज़्यादा इनर्ट होता है. यूज टू मेक नॉन स्टिक यूटेंसिल्स, जो बर्तनों को बनाने के काम आता है. ऐसे बर्तनों को बनाने के काम आता है जो चिपकते नहीं हैं. एंड यूज टू मेक वॉल जो होती है ना, पिचकारी में वॉल होती है, साइडों में वॉल होती है, उनको बनाने के काम आता है. याद रखो इसको, टेफ्लॉन और पॉलीटेट्राफ्लोरोइथाइलीन. ओके. Then we come to polyacrylonitrile. Polyacrylonitrile, POLYACRYLONITRILE. The monomer unit for the polyacrylonitrile is NCH2 double bond CHCN. This is also known as vinyl cyanide. When there is something attached to the carbon of double bond, this carbon is attached to double bond, and there is something attached to this carbon, then we call this vinyl group. This is a vinyl group, and since cyanide group is attached to this carbon, we call this vinyl cyanide, and it is also known as acrylonitrile. Acrylonitrile is the monomer unit for polyacrylonitrile. So when many monomer units of polyacrylonitrile combine in the presence of H2O2, that is peroxide, we get polyacrylonitrile. This is the structure of polyacrylonitrile, CH2 CHCN. So how we got this? H2O2, this CN is there, but this bond came here and this bond came here. What has happened? Free radical is formed. H2O2 is supposed to form free radicals. Okay, it's very hard with high melting point. It's very hard. Polyacrylonitrile is very hard compound with high melting point. Since it is hard, it must naturally have a high melting point. It is made by free radical mechanisms. I told you H2O2 is used when we have to. When H2O2 is used, there is necessarily free radical mechanism. A bond atom from this bond goes to this, and an atom from this goes to this. And good substituent for wool की जगह पर यूज़ किया जा सकता है, used to make blankets, carpets, etc. And so this is acrylonitrile. So we have a preparation for the acrylonitrile too. When this, okay, leave this is enough use. Then we have polyamides. What are polyamides? Polyamides from nylon भी बोल सकते हैं. Polyamides, amide मतलब NH group. Poly मतलब बहुत सारे NH group. तो they are basically condensation polymers होते हैं with amide linkage. मतलब जो लिंकेज होती है वो amide ग्रुप्स के बीच में लिंकेज होती है, और डायमाइंस और बायोकार्बोक्सिलिक एसिड के कंडेंसेशन पॉलीमर से पॉलीअमाइड बनाए जाते हैं. कंडेंसेशन पॉलीमर मतलब कंडेंसेशन पॉलीमराइजेशन मतलब बहुत सारी इसमें कुछ जो ग्रुप्स होते हैं जैसे वाटर या फिर HCl या फिर अल्कोहल ग्रुप्स, ये एलिमिनेट हो जाते हैं कंडेंसेशन पॉलीमराइजेशन में. लेट मी zoom in. So in polyamides we have different polymers. Polyamide is a type, basically condensation polymerization. So this nylon 66 is a polymer. Polyamides, it is a polyamide polymer. Okay, polyamide is not a polymer. Polyamide is a category of polymer. Nylon 66 is a polymer. It is also, this is a polymer, nylon 66, remember this. And the monomer unit used to make nylon 66 is hexamethylene diamine. Hexamethylene diamine is, this is hexamethylene diamine. H2O bond CH2O6 bond NH2. N monomer units of hexamethylene diamine combines with N monomer units of HCOH, CH2, HCOH, adipic acid. This is known as adipic acid, at 525 Kelvin and high pressure. Then it gives result for HN. This, see what happens here. OH from this group and H from this group leaves. Here 2H was there, here H2 was there, here OH was there, here OH was there. Now the result, that is nylon 66, one H is there, one H is here, and no OH is here, no OH is here. And these combine by eliminating H from here, H from here, OH from here, OH from here, and these H and OH combine to form H2O and monomers of H2O. So this is nylon 66 we have prepared. This is the polymer, poly, polyamide polymer. Why polyamide? Because amide linkage is there, amide linkage, NH linkage. And this is a condensation polymer because something is eliminated and more than two monomer units, more than one monomer unit is there. So this reaction is carried out at 525 Kelvin at high pressure. When nylon 66 is, what is the property? When nylon 66 is passed from spinning machine, we get fibers. Nylon is a very strong material and it is used to make mosquito nets also. And by spinning it, we get fibers. Fibers are long threads, very strong threads with a high intermolecular forces. Strongest intermolecular forces we can say that is hydrogen bonding. So then we come to nylon 610. It is this is also a polyamide polymer, nylon 610. In this, n monomer units of same. What was that? What was that? Hexamethylene diamine. N monomer units of hexamethylene diamine monomer units adds combines with the n monomer units of sebacic acid, and this sebacic acid gives result to the nylon 610. This is nylon 610. This is nylon 610 plus 2n minus 1 monomer units of H2O is eliminated. Why 2n minus 1? I don't know. Leave it. Then this is nylon 6 and this is nylon 6. Here also OH is eliminated, OH from here, and H from here, H from here is eliminated, and amide linkage is carried on. Nylon 6s we have this compound we have is this bond, and here is nitrogen, no carbon bond is here. Here is NH group, that is amide group, and double bond with oxygen. This is also known as caprolactam. This compound is known as caprolactam. One, no, at all the places there is carbon, not at one place. Nitrogen NH group is the double bond of oxygen. This is when this combined with water at 533 to 543 Kelvin, sorry, we get 6 amino hexanoic acid, H3N positive, HCH2 or 5 minus bond COO negative, and when it is heated we get nylon 6 plus water. This is nylon 6, okay, plus water we get. How do we make this caprolactam? How do we make this? We take cyclohexane and carry out its oxidation with nascent oxygen. The oxygen in brackets is known as nascent oxygen. Cyclohexane is reacted with nascent oxygen. Oxidation is taken out. Then we make cyclohexanol. Cyclohexanol is formed, and then this happen. H2O H2O is used as a solvent, and we leave it. This is something used for NCERT purpose. This won't happen. No one will ask you in board exam for this. This will only confuse you. Now it's polyesters. What are polyesters? Polyesters are the condensation polymers with ester linkages. What were polyamides? Polyamides were condensation polymers with amide linkage. Polyesters are condensation polymers with ester linkage. And monomer units here are, what were monomer units there? Biomolecules and, okay, let me see, biocarboxylic acid and diamides for the polymer units. And here the polymer units are diol, OH group, hydroxy group, and dicarboxylic acid. There were bicarboxylic acid. Dicarboxylic acid is here. Give polyesters. Example of polyesters are dacron or terylene. Dacron is also known as terylene. They are not other. They are not different. They are the same. Monomer unit used for the formation of dacron or terylene is taliphthalic acid. Taliphthalic acid. Taliphthalic acid. Since this is condensation polymer, so there should be another monomer unit, that is ethylene glycol. When n monomer units of ethylene glycol combine with the n monomer units of terephthalic acid, then in the presence of CH3COO2 Zn sp2O3, in the presence of this compound at 420 to 460 Kelvin, we get dacron or terylene. This is dacron or terylene. Okay, learn it. And after spinning it, we get fiber dacron. It may be its film. And if we make it spin, you must be knowing the films audio cassette we get in the earlier ages, and me before this time. Now we don't get audio cassettes, we have our smartphones, but earlier we had also audio cassette in which film was a black film. You must have seen this film was made by the dacron or terylene. And if we make it spill, we get millar. This film was known as millar. The compound which that film was made was known as millar. And when we make fiber with this compound, then it's known as dacron. Then it comes to phenol formaldehyde polymers. What is phenol? This is phenol group. You all must be knowing. This is formaldehyde group, HCOH. HCH is there, I think. This is wrong. You must say formaldehyde group. This is phenol. This is HCOH, and this is a hydroxy group. When this monomer unit combined with this hydroxy group, that means some base is taken here. Any base can be taken here. Then we get orthohydroxy. Since this is ortho and phenol is ortho and para-direction group, this will direct CH2OH, combination of these, at ortho or para group, para position, ortho at para position, and O hydroxy, ortho hydroxy, and this was para hydroxy methylphenol. Okay. When 2N monomer units of this methylphenol combines, 2N monomer units of methylphenol combines, it gives result to this. CH2, OH is left from here, OH is left from here, and when this combined to formaldehyde groups of N monomer unit, this is known as Novalec. This is a linear polymer. It gives result to this. This is known as backlight. This is OH. This is phenol. This is phenol. This is phenol. This is phenol. All phenols are combined with CH2 group. Between every phenol group, there is CH2 group. Phenol, phenol, CH2. Phenol, phenol, CH2. Phenol, phenol, CH2. CH2, phenol, CH2, phenol, 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 CH2, phenol, CH2, phenol, CH2, phenol, CH2, like that. Okay. This is known as backlight. Backlight is also a polymer. So now it is melamine. You know what is melamine? Don't worry, I also don't know. I think I know. I think I don't know. I'm forgetting it. This is melamine from formaldehyde polymer. Formaldehyde is HCHO. This is melamine. On every alternating position, there is amine group and nitro group. On alternate position, there is amine group. On nitro group, this is melamine. This compound is melamine, and this is formaldehyde. When they both combine, they give result to this compound. You see only from here CH2OH is added here, only here at one amino group. It may be here, here or here. It could be here or here or here. Added CH2OH is added at any position, and when this compound gives this on its own, it also reacts with formaldehyde. There were n units of formaldehyde, and this reacts with n units of formaldehyde. This gives result as this. Melamine formaldehyde polymer. This is melamine formaldehyde polymer. This is an intermediate compound. There are n monomer units and H2O eliminated. So this is condensation polymers. Nitro group at alternating position, and NH2 and NH. H is eliminating from here and OH is eliminating from here. Therefore, the eliminating group is H2OH, 2H and 1O, H2O. For polymer, since more than one monomer units, and condensation polymer, because why condensation polymer? Because water is eliminated. Now we come to rubbers. What are rubbers? Okay, rubber is also a polymer. Rubber can be of many types. We have classified polymer into three types, that are synthetic polymers, semi-synthetic polymers and natural polymers. So rubber can be of any type. Rubber can be natural, rubber can be synthetic, rubber can be semi-synthetic. What is natural? Natural polymers are those polymers which we derive from nature, which we get from nature. So we get rubber in the nature in the form of latex. There are rubber plants. Rubber plants give us latex. What is latex? Latex is a colloidal solution of rubber particles in water. This when natural rubber is formed by latex. Okay, so natural rubber is formed by latex. We have natural rubber. Then we have synthetic rubber. Synthetic rubber is man-made rubber. And synthetic rubber is man-made rubber. Synthetic polymers are prepared by man in our laboratories or factories. And then we have semi-synthetic polymers. What are semi-synthetic polymers? Which are derived from nature but cannot be used as they was. They undergo certain modifications and then we use them. Semi-synthetic polymers. So vulcanized rubber is an example of semi-synthetic polymer. Vulcanized rubber is used as semi-synthetic polymer. Okay, so now we discuss natural and synthetic rubber. We get latex from rubber plant. Latex is a colloidal solution of rubber particles in water, and then we get natural rubber is prepared by latex. Both natural and synthetic rubbers are made from polyisoprene. What is polyisoprene? Polyisoprene is monomer unit of natural synthetic rubbers. This is isoprene and various polymers, बहुत सारे polymers, many units of this isoprene combined. This is polyisoprene. This compound geometrical isoprene is polyisoprene or isoprene. Wait, yes, I have. See here. Okay, I think my throat is choking. I will explain it later. The rubber part, natural and synthetic rubber part. Okay, thank you.